Solving indices questions. So there's two types of questions I ask you on the exam for core 1. So the first one is where you have to simplify indices, and the other one is solving indices. So we're going to have a look at a few solving indices questions. We're going to do 3 in total. When solving indices, it's really important that you remember what I would call the powers timetables. So like the power of 2 is 2, 4, 8, 16, 32, 64. And ideally it's good to know the power of 3 timetable, the power of 4. Power of 4 is really easy because it's very similar to the powers of 2. And then 5 and the 6. 6 you don't really need to know as well, and you probably only need to know it to about 216. But recognising numbers that are in the same inverted commas powers timetable is really useful for solving these sorts of questions. Okay, so let's have a look at the question. Solve 3 to the power of x plus 1 multiplied by 9 to the power of x is equal to 81. Okay, so I'm looking for kind of a powers timetable. So 3, 9 and 81 are all a power of 3. So first of all, let's convert those numbers into powers of 3. So 9 is 3 squared and 81 is 3 to the power of 4. So we can put that in. Okay, that's making it much more simple for us to solve now. So the next thing to do is let's look at our laws of indices. So if I have 3 squared all to the power of x, and that's the same as 3 to the 2x. So we can change that through. Okay, so the next law that we need to know is if I multiply powers, then I would add the small numbers. So I now need to add the x plus 1 and the 2x, and that gets we'll simplify those powers. Okay, so x plus 1 plus 2x is 3x plus 1. Okay, that makes it much more simple because now we have 3 to the power of something equals 3 to the power of 4. So that something must equal 4. So 3x plus 1 is equal to 4. So 3x must be equal to 3. So x is equal to 1. Okay, the other type that might come up, not as commonly, is something like 16 square root 2 is equal to 4 to the x. Okay, so remember again your powers times table. So 16, 2 and 4 are all in the 2 inverted commas powers times table. So I think 16 is 2 to the power of 4, root 2 is 2 to the power of half, and 4 is 4 squared. Okay, so remember the laws of indices that we used last time. 2 squared, all to the power of x will be 2 to the 2x. So let's change that. And 2 to the power of 4 times 2 to the power of half is the same as 2 to the power of 4 plus a half. So 4 plus a half is 4 and a half, which is 9 over 2. Okay, so 2 to the power of 9 over 2 equals 2 to the power of 2x. So that tells me that 9 over 2 is equal to 2x. So x must be equal to 9 over 4. Okay, the last example is a past paper question. This is from about 2 or 3 years ago. So solve 8 bracket times 4 to the power of x bracket minus 9 bracket 2 to the power of x bracket plus 1 equals 0. Okay, so let's think about things in brackets first. So 2 and 4 are both in the 2 inverted commas power timetable. So let's change 4 into 2 squared. Okay, now remembering the law of indices when you have a bracket, I now need to find 2 to the 2x, because that would be 2 squared all to the power of x. But because 2 times 3, for example, is 6, and 3 times 2 is 6, I can swap those around to give me 2x to the power of 2, and that's the real trick with this question, is remembering to do that. And we're going to need to do something similar when we get to core 2 as well, so it's a really important thing to remember for both modules. So now I have something squared minus 9 of the something plus 1, so it looks a little bit like a quadratic. So a trick here, and this is going to be a trick again in core 1, 2 and 3, is to change that thing to a letter. So I'm going to call 2x equal to y. If I call it y rather than x, then I won't get confused. So that will give me 8y squared minus 9y plus 1 equals 0. Just remember though that you have made your y as 2x. So now that looks like a quadratic, so I can factorise that. So I'm going to need 8y minus 1 times y minus 1. I can tell that because obviously I have plus 1, so I'm going to need 2 negatives to make the minus 9, and then I can just try either 4 and 2 or 8 and 1. Obviously I need a 9, so it'll be 8 and 1. Okay, so now I have that. I can get those brackets that I've just done. So either the 8y minus 1 equals 0 or the y minus 1 equals 0. So y is equal to an eighth or y is equal to 1. Now some people accidentally leave that there thinking that they've solved it, but think about your original question. I'm solving things as 2 to the power of x. So just remember that you said that y equals 2 to the power of x. So let's change y to 2 to the power of x. So 2 to the power of x must equal to an eighth, or 2 to the x must equal 1. Okay, now we've got to find x. Okay, so this is quite a long question. So now we know that 2 to the x equals an eighth, or 2 to the x equals 1. So in order to get an eighth, we'll need to find 2 to the power of minus a third. Any number to the power of 0 is equal to 1. So we need 2 to the power of 0 equals 1. So that must mean that x, if you compare the first line and the second line, x must be equal to minus a third, or x is equal to 0.